I mentioned in the very first video for the module that a lot of the kinetics of nuclear decay are the same as those for a first order reaction, which we already covered in module 11. And so the equations that we're using here, the equation for half-life and then this equation here, are the same equations that you've already utilized, except the only difference is here we're using n and n sub 0 because this can refer to grams or it can refer to number of nuclei, whereas before what we had here was A and A sub 0, which was concentration. So the equations are used the same way, but what I want to go ahead and work a couple of problems because I noticed that in module 11, sometimes you guys were making these problems harder than you needed to make them. So I want to make sure, I'm going to work two problems and show you that sometimes there's a shortcut that you really need to pay attention for so you save yourself a lot of work. All right, so I gave you a sheet that has two problems on it, and so we're going to work those two problems together. So the first problem says a nuclear research lab has a container with 57.57 grams of a radioisotope. The half-life is 21.90 days, and how much of the radioisotope is available after 80.59 days. Okay, so I've listed all of that given information here. Here's the amount of isotope that we start with. Here's the half-life. We want to know how much is left after this time period. So the first thing I'm going to have to know, in order to use this equation, I have to know what K is. And so I'm going to use this to figure out K. I know that the half-life is 21.90 days. And so if I plug that into this equation and I solve for K, I should come up with 0.0316 per day. Okay? Now I can use this equation with the K that I calculated to figure out how much of my radioactive isotope is left. So N is what I'm trying to find. My N sub 0 was 57.57 grams. And then I'm going to have e to the negative, K is 0.0316 per day, and the time is 80.59 days. Okay, so obviously those units cancel out. This is going to be 57.57 grams times e to the negative 2.55 to equal N. And then you should end up with a number of 4.50 grams that is left. Okay, that should look very, very similar to problems that we've already done. So it shouldn't be anything that's going to be too difficult for you. Okay, but as I said at the beginning, don't make these problems more difficult than you need to make them. So let's look at the second problem now. Thorium-234 has a half-life of 24.1 days. A lab technician purchases a 74.80 gram sample for an upcoming study. The technician becomes unexpectedly delayed and does not get to the thorium until 96.4 days later. What mass of the original isotope still remains? Okay, so on the surface, here's the given information for that problem. And here's the given information for this first problem. And you see that we have the same information given here as I do over here. I still know the half-life, I still know the amount of time, I still know the initial concentration or the initial amount, and I want to know the final amount. But if you watch and you're careful, you can save yourself from work, or a lot of work, because in this case, the time is 96.4 days, and the half-life is 24.1 days. And what you will find is that if you divide those two, it comes out even. And so I actually have 4 complete half-lives that have passed. Okay? So if I know the number of half-lives, then it's relatively easy just to take the initial mass that I had and just divide it down. So here, if I say this is my number of half-lives, and then here's my mass, before any half-lives have passed, I had 74.80 grams. Okay, you know after one half-life passes, that number is going to get divided in half. So that's going to be 37.40 grams. If I have a second half-life that's passed, I'm going to divide it in half again, and I'm going to get 18.70 grams. After a third half-life, I take that number and I divide it in half again, and I get 9.35 grams. And then my fourth half-life, divide this in half again, I'm going to get 4.675 grams. Okay? So, final answer, if I watch my number of significant figures, final answer is going to be 4.68 grams. Okay? Now, that was a whole lot easier than having to worry about natural logs and all that kind of stuff. So, as you're working these problems, just watch and make sure that if you are able to just divide your time and your half-life and come up with a whole number, then you're going to just be able to do some division by 2, and you're going to have the answer relatively easily. So watch that and don't make more work for yourself than you need to.